Welcome to the Calculus, a collection of micro lectures, video lessons, and sample exercises. Let's apply the differentiation rule in computing the derivative of this given composite function. So our function here is another trigonometric function raised to a power of 7. So you have here tangent of x raised to the power of 7. This is clearly a composite function where you can have h of x being x to the power of 7, that's 7, sorry, and your g of x being tangent of x. This case, our f of x is just actually h of g of x. Don't worry about this one. I'm just trying to illustrate that our function is really composite. So we'll have this form where the entire g of x, in this case tangent of x, is the x raised to the power of 7. That is why you have here 7, and then you have your tangent x, which is your g of x. So just illustrating this so that we can really use here the chain rule as the rule of differentiating composite functions. It follows that if you have an f of x which is a composite function of other two functions, in this case h and g of x is what is the new x for h, its first derivative is equal to the derivative of the h of x, in this case this one, treating this as just one entity, in short only using the rule in differentiating power, times g prime of x, the derivative of what's inside. Okay, so with this now, let's illustrate the components one by one before dealing with the final form. So we are trying to differentiate this, treating this as one only using the exponent. So the rule for differentiating a power, 7, in that entire expression tangent x, and 7 minus 1, which gives us 7 tangent x raised to the power of 6. Other references would like to write this as 7 tangent 6 to the power of x. Similar thing to our expression here earlier in our original function, this could also be written like that. Okay, other references shows it like that. So let me use this, okay, or you may use that. I'm just going to use this final form. Now for our g prime of x, it's just simply the derivative of g of x, in this case tangent x, the function inside. And we know that the derivative of tangent x is the square of second. Take note that I did it like this because the square is on the second. This is also equivalent to the square of second x. But basically we write it like that. That is why I am choosing this aside from this. Hopefully that's clear. Now that these two are already done, let's proceed now to our final form. The chain rule, or the rule in differentiating composite functions. Okay, the derivative of the entire function, this one here, which is this, you will have 7 tangent, then you have 6 x. These are all to be multiplied by g prime of x, which is the second squared of x. Simply removing the grouping symbol, you will have 7 tangent 6x and second squared of x. This is already okay, and this is the result for deriving or on deriving the given function. Again, very familiar with the composite function, and then the chain rule as the formula as it is. Thank you very much for watching. So what are you waiting for? Subscribe now.